Hello everyone, my name is Maddie, and today we're going to talk about the Fundamental Theorem of Calculus Part II. So I've written what the Fundamental Theorem of Calculus Part II is below, and what it does is it pretty much tells you how to take the definite integral of something. So if we want to find the definite integral, and definite just means that the upper and the lower bounds are defined. So if we want to take the definite integral of little f of x from a to b, first we would take the antiderivative, and big F of x is the antiderivative. And then I would draw a straight line to signify that I've already taken the antiderivative. I plug in b for x into the antiderivative, minus, and then I plug in a for x into the antiderivative, and that is going to give me the integral. So let's go ahead and try some practice problems. Okay, so this is practice problem 1. I'm finding the definite integral of 3 to the x from 2 to negative 1. So let's go ahead and solve this. So the first thing that I'm going to do is find the antiderivative. So the antiderivative of 3 to the x is 3 to the x over ln of 3. This is a rule that you're going to have to memorize. I bubbled it in for you. Now I draw the straight line to signify that I've taken the antiderivative, and then fill in my upper and my lower bound. Okay, and now I can start evaluating. So I'm going to plug in b and then subtract and plug in a. So if I go ahead and put that in my calculator, I should get negative 7.89. So that is the integral. So I'm going to split this problem up into 2 chunks. So let's first find the antiderivative of x squared. So the rule is to take x squared and then add 1 to the power and then divide by that new power. So the antiderivative of x squared is x to the third over 3. Okay, so we figured out that x to the 3 over 3 is the antiderivative, and now we're going to evaluate for that first chunk of the problem. So let's plug in 1 and then subtract and plug in 0. Okay, so that's the first little chunk of the problem. We're going to add to this the second chunk of the problem. So first we have to find the antiderivative of root x, which I'm going to do up top in green here. So another way to write root x is x to the 1/2. So if you remember, I'm going to add 1 and then add 1 here. So that makes the antiderivative x to the 3/2 over 3/2. And I can write that, I can further simplify that and write that as 2/3 x to the 3/2. Okay, so now let's go ahead and evaluate for 2x to the 3/2, which I'm going to do. So it got a little messy, so I erased some stuff and moved it over to the left. So I'm going to plug in my upper bound and then subtract and plug in my lower bound. And that, all right, so now we're going to combine everything. So we had 1 to the 3rd over 3 minus 0 to the 3rd over 3. That was from our x squared part. And then we're going to add that to what we got from our root x part, which was 2/3 2/3 times 1 to the 3/2 minus 2/3 times 0 to the 3/2. And so you get 1/3 plus 2/3, which is 3/3, which is 1. So 1 is the answer. I know that was complicated, but that's how you do it.